All right, so we're going to be starting the chapter one notes, and those are going to be about describing phase changes at two scales in this phase change module that we are in right now. Okay, so what is your learning target? Learning target is that I can model and predict changes in particle motion, temperature, and the state of matter as thermal energy is added or removed. Your success criteria is, and you will know that you can do this when you can create a model that shows the cause and effect of the particles as thermal energy changes, explain how particles behave in each phase of matter at the molecular scale. Okay, compare macro scale to the micro scale at each phase of matter. And then you're going to want to score at least 4 out of 5 on the mastery check at the end of the lesson. So, like again, we're going to create a model and it's going to show us how the thermal energy changes with the particles. So let's move on. So the cross-cutting concept that we're focusing on for this lesson is scale, proportion, and quantity. We're describing phase changes at two scales, the macro scale, what we see, and the micro scale, what molecules look like. Now remember, you can have more than one cross-cutting concept in a lesson, but this is the one we're going to focus on. So in the phase change unit, here's our unit question. How can the appearance of a substance change without becoming, whoops, okay, so again, that was how can the appearance of a substance change without becoming a different substance? Okay, so in particles of matter, now right now you guys need to make sure that you have your notes from your note packet out because this is going to help us go through the notes. So all matter in the universe is made of tiny particles that we call atoms. This is the first bullet point on your notes, so make sure that you're copying your notes down as we go. Atoms combine to make molecules. So they come together, atoms come together and create what we call a molecule. These particles are in constant motion. They're constantly moving. Now remember, as we're going through these notes, if you need to pause, please feel free to. Okay, so what is a phase change? A phase change is when molecules that make up a substance experience a change to their freedom of movement. So as the molecules start moving more and more. They're more freely moving. They're not being pulled towards each other. It makes it easier for them to move. So as they move faster, they move away from each other and they're not as attracted. So they can change phase because they have more space between each molecule. So your solid properties are going to be these. A solid holds its shape and does not take the shape of its container. It keeps its shape because its molecules only move in place, not around each other. So they only move right in place. It's like shaking. Okay, if we're looking at a liquid, liquids flow and they can take the shape of their container. So they're going to actually take the shape of whatever the container is, round, square, whatever. A liquid can flow because its molecules move around, not away from each other. They just move kind of around and slip and slide past each other. All right, then let's look at a gas. So a gas has no visible shape, but it does fill its container. So it's going to fill the container all the way up no matter how much you put in. It does not have a visible shape because gas molecules can move away from each other. So they don't take up a specific shape. They can move away from each other. What causes a phase change? Let's talk about that. A change in motion causes different phases to occur in matter. This energy causes freedom of movement within the particles, so they're more free to move. Molecules change phase depending on how much energy is being added or removed. So if you add energy, they'll go in one direction. If you take away energy, they'll go in the other direction of phase change. So the scale in a phase change. This phase change involves a macro scale change in appearance. So you see a big picture scale change in appearance. A change that can be observed at the macro scale can be explained by a change at a molecular scale, like these pictures down here to the right, which cannot be observed by the naked eye. So here you see a big scale change that can actually be explained by something that's happening at a very small level with the water. Okay, so the process of phase changes. First, you have melting. You go from a liquid to a solid, like ice. Okay, melting down. Freezing is from a liquid to a solid. Oops. All right, let me try that again. I think I goofed. First one is melting. We go from a solid to a liquid, so like ice. Freezing goes from a liquid to a solid, so when you're freezing ice. Condensing is from a gas to a liquid, so that might be like drops on the side of the container like this one right here. Evaporating is going from a liquid to a gas, like water does on a hot day outside. It goes from a liquid to a gas. The next one is sublimating. So sublimating is going from a solid to a gas like dry ice does. And then you have depositing from a gas to a solid. So that would be when it kind of drops out of the air and becomes a solid. Okay, modeling phase change. So you're going to fill in the blanks on your diagram. So as the temperature increases, the thermal energy is going to change. As you increase the temperature, there's going to be an increase in thermal energy. And we go from solid to a point, and then the solid will keep melting, 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 melting until it all becomes a liquid and the temperature will raise. And then it will keep raising until all of the liquid turns into a gas. Okay, and it will stay constant as it's turning to a gas. When it becomes a gas, then temperature can rise again. These spots here mean that it is in transition, or it is changing from one state of matter to the other, and what's changing has not fully changed, so the temperature can't rise until all of it has changed to the different state of matter, and then the temperature can rise. So now what I want you to do is I want you to fill in these spaces here. I want you to decide, what do we call it when it is going from a solid to a liquid? What do we call it when it is, you see this arrow here? So you're going to write that right here. What is it called when it goes from a liquid to a gas? What is it called when it's in that transition state here? And then we're also going to fill in gas back to a liquid down here on the bottom. Same thing with liquid to a solid down here on the bottom. Pause the video and answer those now. Okay, let's see if you guys got those right. All right, so from a solid to a liquid is called melting. So melting from a solid to a liquid, that's the transition state here. From a liquid to a gas is called evaporation. So that's going to be what we're going to call it when it goes from a liquid to a gas. Now let's look at it going the other way around. So from a gas to a liquid, we call that condensing. From a gas to a liquid, so that would be like drops on the window. Like in the morning, the dew on the window or on the grass. Okay, from a liquid to a solid, we call that freezing. So that's going to be our different different transformations, or what we call it as it is in the process of changing its phase. Then we also have, if you go straight from a gas to a solid, that's called deposition. And if you go straight from a solid to a gas, that's called sublimation. Now, you also have to remember that temperature is going to be increasing to make these things change as they warm up. So remember, as that temperature rises and the phases change, that means the thermal energy in each of these substances is also changing, and that is what causes it to change from one thing to another. Now, hopefully this will help you with this next. Okay, so your assignments for today are for you to do your must-dos. Your must-dos are phase change, which is lesson 1.1 pre-assessment, and that is your pre-test. Make sure you guys do your best on this assignment so I can see how much you already know. Then you have the chapter 1 video notes with this lesson, which you should have just taken as we were going through this video. So if you've got those, awesome, you've got that done. And then you have lesson 1.2 parts 1 through 3 only. If you get done with those before the end of the class period, then you should work on the should do's. Number 2 is going to be lesson 1.2, and it's both of the homework assignments. Those should help add to your understanding and help bump up your grade as well and add to your grade. So the last thing is, if you finish that, you can start on the Aspire to do. That will be the number 1 brain pop, the matter changing states assignment. So you can start working on that as well. All right, so great work today, you guys, and have a great time doing this. If you have any questions, feel free to make sure that you guys hop on and let me know that you need help, or flip that card over so that I do know that.